Okay, back again. This is part 3, chapter 8 material. Now, I will show you, or we'll come up with a picture that represents this situation here. A complement subset of B. And this is probably something that would not occur to you, but here is B, and here is something that might not occur to you. I can draw the set A complement just like that. A complement's a set, and it's inside B. Now, that might seem very strange to you, but if you think about it, there's nothing wrong with this picture, right? And remember, the whole rectangle represents the universal set U. So what does A union B look like? Well, the set A is everything outside A complement. Let's shade that in green. Okay, that's the set A. And we want to take the union of that with B. So let's shade B in yellow. That's everything in the set B, which includes A complement because of the given condition here. So does that shade everything? Is everything shaded? Yes. So this is true. Now, the tricky part will be proving it. So let's try. We will use a direct proof, I think. So, what do? We suppose that these conditions hold. All right. So, note that it is always true that this first direction holds. A union B is always a subset of the universal set, right? So we need to show that the universal set is a subset of A union B under this condition, of course. So let's let X be an element of U. Now here is the key. X is either going to be an A or X is going to be an A complement. Because why? Well, A union A complement is the universal set, and this is a disjoint union. That means they have nothing in common. So one of these has to be true, and both of them can't be true in this case. So let's check them both out. If X is in A, then what do we know? What are we trying to show? That it's in here. So if it's in A, it's definitely in the union, A union B. Okay? What about if it's in A complement? Well, we have this condition. Now we're going to use it. Since A complement is a subset of B, X is in B, And what does that mean? X is in the union. So we showed that if you take an arbitrary X in the universal set, it's also in the union of A and B under these conditions. So we have both directions, and we're done. So if A complement is a subset of B, A union B equals U. So that was a little different than just a straightforward proving of set equality because we had a conditional statement. But the way we start is assume that P is true and then show that Q is true. And when we're showing that Q is true, we have to do the set theory proof by showing that the subset relationship goes both ways. Now we got one way for free because no matter what, the union of two sets is going to be a subset of the universal set. So we just had to then show the other direction. All right, I think we have one more to look at. Let's draw a picture. So what has our picture got to be? Where again, we have A as a subset of B. And now we want to know, is this true? Does this equal the empty set? Well, let's find the intersection of A. So I'll shade A in blue and B complement. I'll shade B complement in red, and I think you can see right away there is no overlap between these two sets. Right? So this is true. So now we have to prove it. So I'm thinking contradiction. What about you? We have this statement involving the empty set, and if you try a direct proof, you're going to run into trouble, I think. So let's say, suppose not. Suppose A is a subset of B, but A intersect B complement is not equal to the empty set. So now what can I do? Well, if this is not the empty set, then there is something in there. So let X be an element of this set. Then what does that mean? Then X is in A and X is in B complement. So this means X is in A and X is not in B, right? That's what it means. However, what? Since A is a subset of B, if X is in A, we have X is in B. So this is a contradiction. Let's write that better. So we have X in B and X not in B, a contradiction. And we are done. So, okay, so your job is to try the ones that we did not look at, A through H in the handout, and to try the selected homework problems. Do not do all of them. These proofs can get very tedious, and we don't want to spend a whole lot of time on doing set theory proofs. They're important, they're good exercises for your brain, and they will come up um, in your career as a math major, but we have more exciting things to get to. So let me know if you have any questions. Bye for now.